Hello calculus students, this is some hints for doing review pack 2 number 86 involving a lot of lines of concurrency and triangles. First, use the triangle you used last time in review pack 1, and that way you can make sure everybody does a different triangle. So look up what you had in review pack 1, otherwise I have some records on that. Okay, for setting up your triangle, first let's try and get the grid on. So come on up here to options, couple things. Under point capturing, put it on snap to grid so you get a whole number point, and you also want to make sure, or integral point, you also want to make sure it's not equal to 0. And also, let's actually view the grid. There we go. And before we get started too, for options, do your rounding out to 5 decimal places for your answers and so forth. So we get that all set up. And I'm just going to make the font size a little bigger so you can see what I'm doing. Okay. Here we go. So let's put some points down. Click on the point tool, and it should snap to grid nicely there at, let's say, -2. It'll be up here at 3, 4. And if I come over here, let's say I pick this point right here at 5, -1. Okay, there are my 3 points. Now I'm going to make the segments connecting those. And just so it labels them correctly, so that I have side BC labeled as length A, I'm going to click on BC first. And there's length A. And then I want length B to be AC. So let's click on these next. C, A. So there's length B. And then side C, so I'll click on A, B. Now if that didn't work out nice for her like that, you can always just rename the objects. So C is the length of the side opposite angle C. And because this is our base triangle, I am going to go ahead and select all these. Now watch the selection trick. I click on one and then hit Control, click on another, hit Control, click on another, and now I can change all the properties at once. So I go to Control E to look at all the properties. And I just want it a little thicker so you can see it. Okay. There's our base triangle. Now as you can see, I violated one of the rules. It's not scaling. So I'm just going to change my side B here a little bit to be, let's see, up here. There. Now all sides are different. Alright. Okay, so our first project is the centroid, a meeting of all the medians. So for the centroid, you want to get the midpoint of all the sides. So we can actually do that all at once. We can use the midpoint tool up here too, midpoint or center. You can go along and click on these. Let's start here. There's our midpoint D, E, and F. Those are the midpoints of the sides. Now the medians connect a vertex to the midpoint of the opposite side. So here's our medians. A to E, B to F, and C to D. And notice how those were all concurrent. We want to focus on just one of the intersection of one of those points. So we can come here to intersecting points. This one. Intersecting objects, so let's intersect these two. And sure enough, it lies on DC as well. Okay, and that's the centroid. So I'm going to start by renaming the centroid. Renaming G as the centroid. Okay. And then everything associated with the centroid I'm going to mark with red. So the centroid itself, and the lines we put up over here, these segments, which were DEF. Hit Control E to adjust the properties, and let's make these all red. Okay. All right. Now, as you move on, you should make sure that you've got a dynamic diagram. So go back and grab one of your original points and see if the centroid is still staying where it's supposed to be. There you go. Intersection of all the medians. All right, so that's the centroid. Now, I want to keep the centroid in there. I'm just going to unhighlight the construction parts for it so it doesn't confuse my next steps. All right. Now, the next is the orthocenter, the intersection of the altitudes. The altitudes are when you take a point and go perpendicular to its opposite side. So we use the perpendicular constructing tool. I select the point B, let's say, and the point and the side opposite to it, and there's the perpendicular line. That's an altitude. So now I do this with C and the side opposite, and with A and the side opposite, and they're concurrent. The altitudes are concurrent. So let's find that crossing point between this line and, oopsie, something's not right there. Find the intersection of this line and this line. There's G again. That's our altitude, and before we start going around, let's make sure they all stay concurrent, and they do. Notice how sometimes this goes outside the triangle, sometimes it's inside the triangle, sometimes it's right on the triangle. Can you see when it's right on the triangle? That's right, at right angles, at right triangles. So let's just get back this down here. Now let's label G now. Let's give it a new label. Rename it as, call this the orthocenter. Orthocenter. Okay? And let's associate everything with the orthocenter with orange. So that's the orthocenter, on these lines, G, H, and I. Control E, and let's change the color to an orange. Okay, so there's the orthocenter. Now I'm just going to unhighlight our correction lines there just by clicking on the little knob there. And we're ready to go on. Our next one is the circumcenter, the intersection of the perpendicular bisectors. So I'm glad I left these midpoints in here, because now we're going to go perpendicular each side, but instead of using the opposite vertex of the side, we're going to use the midpoint of the side to make the perpendicular bisector. So we go to our perpendicular maker here and hit the point D and the side that D is on. Hit midpoint E and the side that E is on. Hit midpoint F and the side that F is on. And those look concurrent. Let me just slide this around so I can see that a little better. Grab C here and move it somewhere else. It's not letting me grab C. Hang on. There we go. Grabbing C and moving up here just so I can see that F point a little better. There's F. Let's verify the intersection by clicking on two of them. There's G again. So now let's rename G as the circumcenter. Circumcenter. Now, do you remember why it's called the circumcenter? It is the center of a circle. Which circle? The circle that circumnavigates the triangle, that goes through all the points of the triangle. So I'm going to go to my circle generator tool, circle through center and point, click on the circumcenter and any of the corners of the triangle, and sure enough, all three sides are on it. Now let's see if that stays true as we move things around. Sure enough, the circumcenter moves around. Sometimes it's outside the triangle, sometimes it's inside the triangle. Okay, let's label those points. So, the circumcenter, let's associate with green. So the circumcenter and everything we did with the circumcenter, now that would involve basically all this other black stuff. The lines, which are the perpendicular bisectors, and this circle kind of demonstrating the circumscribed circle. Control E, and let's make them all green. Okay, that's the circumcenter. Everything seems hunky-dory there. Let's go on to our next one. I'm going to unhighlight anything, all these construction lines. And now let's go on to the in-center. The in-center is the intersection of all the angle bisectors. So we come over here to our construction tools, and there's angle bisector. And it says you select 3 points or 2 lines. So I'm just going to select the points in the corner here. D, A, and then that midpoint F. There's the one angle bisector. D, B, E. There you go. And then E, C, and then F again. There. They're the angle bisectors meeting right there. So it looks like they're concurrent. Here's our concurrency point. There's the intersection of any 2 of these. Oopsie. Undo that. I don't know what that was. Just go for the intersection of this angle bisector and this angle bisector. Maybe we get G again. This is called the in-center. So I'm just going to rename this as the in-center. Okay. And why it's called the in-center? What's the center of the inscribed circle, that circle that goes inside here? Now be careful in drawing your in-center, your inscribed circle, because a lot of kids just click on this center here and then click on what they think is where it crosses. Let's find out exactly where it crosses by doing the perpendicular line tool. So we click on the in-center and then click on any of the sides, and where those cross, that's the point of tangency of the inscribed circle to the bigger circle itself there. So now I can do circle by center through a point in center and that point G there, and now it touches nicely on all of them. And as we move it around too, you can see that the in center stays at the center of the inscribed circle. So, which means it's always got to stay inside the triangle, can't get out. Alright, let's get everything associated with the in-center in blue. So that's that, and it's not those sides of the triangle, but everything else down here. We had a lot going on there, didn't we? We had all these angle bisector lines. Apparently one of the angle bisectors got done twice. And then that inscribed circle. Control E, and we'll make them all blue. Okay, that's the in-center. Now let's hide all those construction lines, and we'll be ready for our next construction. Okay? Now before we go on, let's take a look. Before we go on to the flange point, let's take a look now what's going on with these key points here. We've done 4 so far: orthocenter, in-center, center, and circumcenter. And I think you can see that some of these are lining up, some of them are not. Start seeing if you can figure out which one is the odd one out in terms of our lineup. And let's go on to the flange point. Now you can use your flange point that you had from before. So if you got that calculator, you could add to your graph. Otherwise, it's fairly straightforward, especially with what we got set up here. Remember, in constructing the flange point, you want to make a circle centered at every corner. And it's really easy since I set up the sides. Notice you might want to check this. Is your side A, which is that side, yeah, that's opposite vertex A. And side B is opposite vertex B. And side C is opposite vertex C. That's going to be handy now, because when we construct the actual triangle or circles, I'm going to construct them by circle with center and radius. So I click on A, I can say radius little a right away. I've got my circle. Click on B, and I can say radius little b. And click on C, and say radius little c. Okay. Now, from watching live, you make your flange points. This is probably one of the things that was the frustrating thing, is getting the right two intersections. Well, to do that, just click on two circles. Go to your intersect and click on two circles. And it'll give you both the key points of intersection there. There's H and, gotta move over here to find the other one. There's I. So there's two new created points. Those are the ones you want to create a flange line with. So we go to our line maker, and we click on H and I, and that's one of the flange lines. Okay, then click on another pair of circles for your intersection. Let's intersect these two circles, this one and this one, this circle and this circle, and there's J and K. So you want to get the line through those right away. That's another flange line, J, K. And finally, there must be another pair of circles. If you don't see where they're crossing, you can also kind of move your points around so you can see the intersections better. Move the graph around. Yeah, something. It's because we have such a scaling triangle. You can change the scaling. You can also start moving some of these around. We've got our point of concurrency already. There it is. I just want to come up with the other intersections and make some of these triangles not quite so big. So where's our other point? There are the intersections. There's one of them. So here's one of them. And the other one must be way up here somewhere. So we just have to move the graph over this way and this way. There you go. There are your two intersection points. There and there. And we can see that now when we go for the intersection. This circle and this circle. There's L and M. Let's get a line through those two. L to M. And there are three flanced lines come together in a single point. So now we look for our intersection. Any two of these flange lines. There it is. And N we want to relabel as the flange point. Okay. Now, so the flange point and everything associated with it, we're going to call purple. All right. So we've got a lot to label here. Yeah, there are a lot of new points and intersections and so forth. D, E, and F, we want to keep those as they are. But basically everything else in black, this G, H, I. No, the G was something else. I, H, I, J, K. Yeah, we don't want to start with H. So H and I and J and K and L and M, those were the intersections of the circles. Side A we want to keep in there. These were some of the lines we just came up with. A1, B, those are the flange lines. Some of the circles involved with finding the flange point. And there's the flange point itself. And there's another circle associated with the flange point. Control E. Let's make them all purple. Okay. Now we can go through and highlight everything, unhighlight everything in purple, just to get that all cleaned up. So we can focus now on all our special points, our points of concurrency. And we'll leave the flange point in there. Oh, we still got a couple circles here yet. There we go. There's a circle. And we have one more purple circle here somewhere. I must have missed. Here it is. There. Okay. Now, focusing on the graph, it looks like they all line up here, but that's because we're close to an isosceles triangle. If you make an isosceles triangle, you're going to find that all the points line up. Let's make it isosceles. There's your isosceles triangle. And if you make it an equilateral triangle, you can get all the points to actually be the same point. So here's the equilateral triangle. It'll be somewhere up in here. Can't get it quite exactly. There we go. So they're all coming together in the equilateral triangle. That could be my scaling's a little different here. Why it looks like it's not a nice equilateral triangle right now. Because I think I might have stretched the scaling a little bit different here in these two. Or yeah, this is 4 and 4. But now as we come off of the isosceles triangle, we see one point that's not lining up with the rest. And if you really exaggerate things here, you can see it. Do you see the point that doesn't line up with the rest? If you go through the orthocenter and flange point now, we can come up with what we call the Euler line. Going through the circumcenter and centroid and orthocenter and the flange point, but not the incenter. So even as we move things around, even as we grab point C or point A or anything like that, it's the incenter that doesn't line up. Okay, and this new thing we created is called the Euler line. Let's label it as such. Where'd it go now? Here it is. Let's come up with a, rename it, the Euler line. Okay? And also, there's the Euler line right there. And also what you can do is right-click on it, and you get the equation in y equals mx plus b form. And I want you to do that. Otherwise, everybody's going to have slightly different things. This way, you can look at the slope and look at the y-intercept and see how you're changing the slope and y-intercept as you move other points around. So the Euler line changes. Okay, so what do I expect to see from you on this for your output? Because I want you to print up your results and print up the whole thing. Print up this stuff too. You might want to go back to a different font size so it all fits on one go. And the key things, though, are the coordinates of all the key points here. Everything in color here. I want the coordinates of those. And the equation of the Euler line. Okay? That's what's required for the project. And good luck. One last I'm going to make a brand new circle, and let's call that, I want to be able to control both points, so let's just say it's here, N-O, circle no. And I want to put all the corners on that circle. So I use this special tool called attach detach point. I'm going to take this point and attach it to this circle. There you go. I want to take point B and attach it to this circle. And point A and attach it to this circle. So now I want to study what happens when these points are all on the center of a circle. Notice how the circumcenter isn't moving around. Because basically I put the 3 points on the circumscribed circle. They're on a circumscribed circle. But let's see what happens to the other points now as I move the things around the circle. So here goes. I'm going to select the other points. I'm going to change my scaling just a little bit so we can see, because it looks like sometimes we miss out on where the flange point and orthocenter are going. So I want to just change the scaling a little bit. object's center a little more. Maybe turn off the axes and turn off the grid. And as we move point A around this circle, we can, we just gotta go, we change. I gotta put the grid back on, or zoom out just a bit. There we go. So now as I move these points around, I am able to see the flange point, circumcenter, and centroid. I want to zoom back in just a bit. There we go. I can also do this trick too. We're able to control the size of this circle by grabbing at point O here. There we go. So if you ever think you're losing out on your orthocenter and centroid, you can do that. Okay. Now to make it a little less confusing, I'm going to hide N and O. And their circle. I'll keep that circle in there. And here comes the trick. I take all these colored objects, other than the circumcenter, which isn't going to move, and I'm going to highlight them. So the centroid, the in-center, the orthocenter, and the flange point. Control E, and under Basic, put them all on Show Trace. Then, for point A, we want to get things moving around. So I'm going to set up point A and turn the animation on. And there you go. As A goes around a circle, so do the flange point and orthocenter and the circumcenter. But the in-center is doing something really strange. Almost reminds me of the moon I saw last night. Half moon, just with a little bit of a bend in it there. And you can change things. So we can grab point O. Oh, we hid point N and O. Let's grab point O just to change the size again. So whenever you make a change, it restart. No, it didn't restart the trace. If I bring this in closer, we get smaller circles now. And that shaped into trans. So, have some fun with that. Flange out.